Good morning, all. So today we are going to see the fifth module, which in which we are going to study about the transducers. Okay, so let's start. So what are transducer? Okay, transducer is a device that is used to convert a form of energy into another. That is, in a transducer, one form of energy is converted to another form. Okay, in a transducer a sensing element will be there, and the sensing element it will fed into a transduction element, and input will be fed to the sensing element, and in the transduction element it is converted into desired physical quantity. So output is fed from the transduction element. Okay, the process consists of sensing the input energy from a measurement. One measurement will be there that will be fed as the input to the sensing element, and transforming it into another form by a transduction element, and that the input is transformed to another form, and output is getting from the transduction element. So this is the general block diagram of a transducer. Input is fed to a sensing element, and it is transformed into a desired form by using a transduction element, and the output is coming from the transduction element. So input can be resistance, capacitance, inductance, stress, strain, heat, etc. Okay, this will be the input, and the output will be desired output will be either force, displacement, pressure, sound, magnetic flux, voltage, current, etc. It will be in a suitable form, generally a electrical form. Okay, generally these all quantities will be there in the electrical form, so that it can be displayed there. Okay, so this is the basic basics about the transducer. It will be having a sensing element where the input is fed, and then that sensed element is converted to or transformed to a desired form by using a transduction element, and from the transduction element we will be getting it as the output in the desired form. So input normally it will be in the form of resistance, capacitance, inductance, stress, strain, heat, etc., and the output will be force, displacement, pressure, sound, magnetic flux, voltage, current, etc. Normally we will be getting it into a electrical form. Okay, as displayed. Okay, and the transducer plays a very important role in any instrument system. For example, a electrical transducer is a device which is capable of converting a physical quantity to be measured into a usable electrical signal. This physical quantity which is to be measured can be pressure, temperature, displacement, etc. That is what same I told here. Like a physical quantity to be measured will be there, that will be the input, pressure, temperature, displacement, etc., and it will be converting into a electrical signal which displays the physical quantity we fed as input into a desired form. Okay, so that is an electrical transducer example, and the output which is obtained from the transducer is in the electrical form and is equivalent to the measured quantity. Input la nammalippo parnallo oru measured quantity, that will be resistance, inductance, capacitance, like that, and the output will be equivalent to that corresponding resistance, inductance, or capacitance what we fed as the input. Okay, for example, a temperature transducer will convert temperature into a equivalent electrical potential. Output can be used to control the physical quantity or displayed. In the output, it can be displayed what all the changes happening in the input temperature quantity which is fed into the transducer, The output also, will be having a desired electrical signal, and we can display that desired electrical signal, and the output electrical signal will be equivalent to the input fed. Okay. And next one is parameters of transducers. ഈ ഫോർത്ത് ഫിഫ്ത്ത് സിക്സ്ത് മൊഡ്യൂൾസിലൊക്കെ കുറേ ടേംസ് ഉണ്ട്. സോ ദീസ് ഓൾ ടേംസ് ഷുഡ് ബി ഫെമിലിയർ ടു യു. ഇപ്പോൾ പാരാമീറ്റർ ഓഫ് ട്രാൻസ്ഡ്യൂസർ ഒഴിച്ച് വേറെ എന്തെങ്കിലും കാര്യം എഴുതി കഴിഞ്ഞാൽ മാർക്ക് കിട്ടില്ല. പക്ഷേ ഈ പറഞ്ഞ കാര്യങ്ങളൊക്കെ തമ്മിൽ ബന്ധങ്ങളുണ്ട്. സോ യു ഷുഡ് ബി സ്പെസിഫിക്. ഓരോ ടോപ്പിക്കായിട്ട് ബന്ധപ്പെട്ടിട്ട് അതിൻ്റെ അടിയിൽ എന്തൊക്കെ എഴുതണം എന്നുള്ളത് ബി സ്പെസിഫിക്. ഓക്കെ. സോ next one is parameter of transducers. So different parameters of transducers are linearity, sensitivity, dynamic range, repeatability, physical size, etc. So linearity means there should be a relationship between the physical parameter and the resulting electrical signal, and it should be linear. അതായത് ഇൻപുട്ടിൽ നമ്മളൊരു ഫിസിക്കൽ പാരാമീറ്റർ മെഷർ ചെയ്യുന്നു, ഔട്ട്പുട്ടിൽ അതിനെ ഡിസൈഡ് ഇലക്ട്രിക്കൽ സിഗ്നൽ ആയിട്ട് നമുക്ക് കിട്ടുന്നു. ഓക്കെ. ഇൻപുട്ടിൽ ഒരു ഫിസിക്കൽ ക്വാണ്ടിറ്റി മെഷർ ചെയ്യുന്നു, ഔട്ട്പുട്ടിൽ നമുക്ക് അതിൻ്റെ റിസൾട്ട് ഒരു ഇലക്ട്രിക്കൽ സിഗ്നൽ ആയിട്ട് കിട്ടുന്നു. സോ ഇൻപുട്ടിൽ ഈ ഫിസിക്കൽ ക്വാണ്ടിറ്റിക്ക് ഉണ്ടാകുന്ന ചേഞ്ച്, ദർ ഷുഡ് ബി എ ലീനിയർ ചേഞ്ച് ഇൻ ഔട്ട്പുട്ട്. ഇൻപുട്ടിൽ ചേഞ്ച് ആകുന്നതിനനുസരിച്ചിട്ട് ഔട്ട്പുട്ടിലും ചേഞ്ച് ആയിട്ട് വരണം, ആൻഡ് ഇറ്റ് ഷുഡ് ബി ലീനിയർ. അതായത് ഇൻപുട്ടിൽ ഒരു ചെറിയൊരു ചേഞ്ച് ഉണ്ട്, ബട്ട് ഔട്ട്പുട്ടിൽ അതൊരു ലീനിയർ ആയിട്ട് വരണം. അപ്പം സപ്പോസ് ഇറ്റ് ഷുഡ് നോട്ട് ബി എക്സ്പോണൻഷ്യൽ. ഇൻപുട്ടിൽ ഒരു സ്മോൾ ചേഞ്ച് ഉണ്ടെങ്കിൽ ഔട്ട്പുട്ടിൽ അതൊരു വലിയ ചേഞ്ച് ആയിട്ട് വരാൻ പാടില്ല. ഔട്ട്പുട്ടിൽ അതിന് സെയിം കണക്കായിട്ടുള്ള ചേഞ്ച് ആയിട്ട് വരണം. അതാണ് ലീനിയാരിറ്റി ഉദ്ദേശിക്കുന്നത്. ഓക്കെ. റിലേഷൻഷിപ്പ് ബിറ്റ്വീൻ ദ ഫിസിക്കൽ പാരാമീറ്റർ ആൻഡ് ദ റിസൾട്ടിംഗ് ഇലക്ട്രിക്കൽ സിഗ്നൽ മസ്റ്റ് ബി ലീനിയർ. ഓക്കെ. നെക്സ്റ്റ് വൺ ഈസ് സെൻസിറ്റിവിറ്റി. ദിസ് ഈസ് ഡിഫൈൻഡ് ആസ് ഇലക്ട്രിക്കൽ ഔട്ട്പുട്ട് പെർ യൂണിറ്റ് ചേഞ്ച് ഇൻ ദ ഫിസിക്കൽ പാരാമീറ്റർ. അതായത് ഫോർ എക്സാമ്പിൾ, ഫോർ എ ടെമ്പറേച്ചർ സെൻസർ, output will be coming as a volt and it will be displaying. Input will be temperature in degree Celsius. So it should be like volt per degree Celsius. Okay. High sensitivity is generally desirable for a transducer. Okay. Transducer should be of high sensitivity. അതായത് ഇവിടെ എത്ര ഇലക്ട്രിക്കൽ ഔട്ട്പുട്ടിൽ ചേഞ്ച് ഉണ്ടായിട്ടുണ്ട് പെർ യൂണിറ്റ് ചേഞ്ച് ഇൻ ഫിസിക്കൽ ക്വാണ്ടിറ്റി. ഇൻപുട്ടിൽ നമ്മൾ ഫെഡ് ചെയ്യുന്ന ഫിസിക്കൽ ക്വാണ്ടിറ്റി, ആ ഫിസിക്കൽ ക്വാണ്ടിറ്റീൻ്റെ ഒരു യൂണിറ്റ് ചേഞ്ചിനനുസരിച്ച് ഔട്ട്പുട്ടിൽ എത്രത്തോളം ചേഞ്ച് ഉണ്ടായിട്ടുണ്ട്, അതാണ് സെൻസിറ്റിവിറ്റി കൊണ്ട് ഉദ്ദേശിക്കുന്നത്. നെക്സ്റ്റ് വൺ ഈസ് ഡൈനാമിക് റേഞ്ച്. ദ ഓപ്പറേറ്റിംഗ് റേഞ്ച് ഓഫ് എ ട്രാൻസ്ഡ്യൂസർ ഷുഡ് ബി വൈഡ്. ഓക്കെ. ടു പെർമിറ്റ് ഇറ്റ്സ് യൂസ് അണ്ടർ എ വൈഡ് റേഞ്ച് ഓഫ് മെഷറിംഗ് കണ്ടീഷൻ. സോ ഫോർ എ ഡൈനാമിക് റേഞ്ച്, ദ റേഞ്ച് ഓഫ് ദ ട്രാൻസ്ഡ്യൂസർ ഷുഡ് ബി high. Next one is repeatability. The input-output relationship of a transducer should be predictable over a long period of time. അതായത് സെയിം ടൈപ്പ് ഓഫ് മെഷർമെന്റ് നമ്മൾ പിന്നെയും നടത്തുകയാണ്. അപ്പോൾ ഔട്ട്പുട്ട് റിലേഷൻഷിപ്പ് ഷുഡ് ബി പ്രഡിക്റ്റബിൾ. അതായത് അത് വേരി ചെയ്ത് പോകാൻ പാടില്ല. വേരി ചെയ്ത് പോയിട്ടുണ്ടെങ്കിൽ ആ ട്രാൻസ്ഡ്യൂസറിന്റെ റിപ്പീറ്റബിലിറ്റി മോശമാണ് എന്ന് പറയും. ഓക്കെ. Also, it is the degree of agreement between the results of successive measurements of same variable carried out under same measurement condition in a transducer. Okay, അതായത് ഇപ്പോൾ നമ്മൾ പറഞ്ഞു, ഇപ്പോൾ സെയിം ടൈപ്പ് ഓഫ് മെഷർമെന്റ് സെയിം കണ്ടീഷനിൽ, ഓക്കെ, സെയിം വേരിയബിൾ. അപ്പോൾ അങ്ങനെ മെഷർ ചെയ്യുന്ന സമയത്ത് ഇൻപുട്ടും ഔട്ട്പുട്ടും തമ്മിലുള്ള റിലേഷൻഷിപ്പ് നമുക്ക് പ്രഡിക്റ്റ് ചെയ്യാൻ പറ്റണം. ആൻഡ് ദിസ് ഇൻഷുവേഴ്സ് റിലയബിലിറ്റി ഓഫ് ഓപ്പറേഷൻ. ഓക്കെ. Next one is physical size. Transducer must be having minimal weight and volume so that the presence so that its presence in the measurement system does not disturb the existing condition. Okay. And transducer should be having a minimal weight and volume so that because of this minimal weight and volume it will not affect the measurement condition. Okay. Next one is classification of transducer. How transducers are classified? Transducers are classified into as following. One, on the basis of method used for transduction. On the basis of method used for transduction can be classified as resistive, capacitive, and inductive transducers. And next one is active or passive transducers. Third, analog and digital transducers. Transducers and transducers. Primary and secondary transducer. These are the different classification of transducer. Now we can see in detail. So on the basis of method used for transduction, transducers are classified into resistive transducer, capacitive transducers, inductive transducers. We will discuss all this later. Okay, so on the basis of method of transduction, it is classified into resistive, capacitive, and inductive transducers. Next one is active and passive transducers. Active transducers are transducer in which we do not require an external power source. It will be self-powered. That is, those are the transducer which do not require an external power source or auxiliary power source to generate equivalent output. They are self-generating transducer. Okay. Example, piezoelectric transducer crystal. It will convert pressure to EMF. ഒരു പീസോ ഇലക്ട്രിക് മെറ്റീരിയൽ നമ്മൾ പ്ലേസ് ചെയ്ത് കഴിഞ്ഞാൽ അതിൻ്റെ വൈബ്രേഷൻ കൊണ്ട് അതിലിപ്പോൾ ഒരു പ്രഷർ നമ്മൾ പ്രഷർ അപ്ലൈ ചെയ്താൽ അത് വൈബ്രേറ്റ് ചെയ്യാൻ തുടങ്ങും. ആ വൈബ്രേഷൻ വെച്ചിട്ട് അതൊരു EMF ജനറേറ്റ് ചെയ്യും. സോ ഇതാണ് ആക്റ്റീവ് ട്രാൻസ്ഡ്യൂസേഴ്സ് എന്ന് പറയുന്നത്. അതായത് അതിനൊരു എക്സ്റ്റേണൽ പവർ സോഴ്സ് ആവശ്യമില്ല, അത് സ്വയം ഇക്വലന്റ് ഔട്ട്പുട്ട് ജനറേറ്റ് ചെയ്യും. ഓക്കെ, അപ്പോൾ അതാണ് ആക്റ്റീവ് ട്രാൻസ്ഡ്യൂസേഴ്സ്. Whereas passive transducers requires external or auxiliary power supply for the operation. Passive transducer external power supply or auxiliary power supply is required for the operation. So those are passive transducer and they are powered transducer. Okay, example, potentiometer, galvanometer. Galvanometer we have seen in last module that it requires an external power source for the measuring variation of resistance. Okay, so those are passive transducers. Next one is analog and digital transducers. An analog transducer which convert a physical quantity into analog form. It will be continuous in nature. For example, thermocouple. Thermocouple, have you seen that the resistance change in resistance, it will be measured in analog form and it is continuous in nature. Okay, it will be a continuous function of time. That is analog transducer. Next one is digital transducer which convert the input quantity into digital form. Okay, this is the form of in the form of pulses having logic 0 and logic 1. Okay, for example, a rotatory encoder. So a digital transducer which convert the input signal into digital form, whereas analog transducer is a transducer which convert it input to a input physical quantity into a analog output. Okay, next one is transducers and inverse transducers. Normally a transducer is a device which is converting a physical quantity into electrical signal by electrical means. Okay, for example, potentiometer. Okay, normally a transducer എന്ന് പറയുന്നത് എന്തായത് ഒരു physical quantity into a electrical form, അതിനെ electrical signal ആയിട്ട് convert ചെയ്യുന്നു. അതിനാണ് normally നമ്മൾ ഒരു transducer എന്ന് പറയുന്നത്. For example, potentiometer. Whereas inverse transducer is a device which converts electrical quantities or signals into a non-electrical quantities. Okay, that is when an electric charge or voltage is applied to a for example, when an electric charge or voltage is applied to a piezoelectrical crystals, ഒരു piezoelectrical crystal നമ്മൾ ഒരു electric voltage അല്ലെങ്കിൽ electric charge നമ്മൾ അപ്ലൈ ചെയ്ത് വിചാരിച്ചു, അത് കറസ്പോണ്ടിങ് ആയിട്ട് അത് വൈബ്രേറ്റ് ചെയ്യാൻ തുടങ്ങും. വൈബ്രേറ്റ് ചെയ്ത് തുടങ്ങിയിട്ട് അതിനൊരു ഡീഫോർമേഷൻ സംഭവിക്കും. ദിസ് ഡീഫോർമേഷൻ, ഈ ഡീഫോർമേഷൻ കൊണ്ട് നമുക്ക് അതിലൊരു ഡിസ്പ്ലേസ്മെന്റ് ഉണ്ടാവും. ആ ഡിസ്പ്ലേസ്മെന്റ് ആയിരിക്കും നമുക്ക് ഔട്ട്പുട്ട് ആയിട്ട് കിട്ടുന്നത്. ഓക്കെ, അപ്പോൾ അതാണ് എന്ത് ഇൻവേഴ്സ് ട്രാൻസ്ഡ്യൂസർ, ഇൻ വിച്ച് വി വിൽ ബി അപ്ലൈയിങ് എ ഇലക്ട്രിക്കൽ സിഗ്നൽ as an input, and based on that it will be producing a non-electrical output. Okay, അതാണ് inverse transducer. That is, when an electric signal, electrical charge or voltage is applied to a piezoelectrical crystals, the dimension of the crystal changes due to deformation. This deformation results into mechanical displacement. Okay, these devices receive input quantity current and voltage, current or voltage, that is electrical quantity, and it is converted into a mechanical displacement or deflection in accordance with the magnitude of the input quantity. So this is an inverse transducer in which input received will be a electrical signal and the output will be a mechanical displacement. Okay, next one is primary and secondary transducer. A transducer which converts a physical quantity into a mechanical displacement is called as a primary transducer. This primary transducer and secondary transducer will be kept together. In that primary transducer, in which will be converting a physical quantity into a mechanical displacement, which a physical a transducer in which a physical quantity which is converted to a mechanical displacement is called as a primary transducer, and it will be a mechanical device. For example, Borden tube. Example we will discuss after this. And a transducer in which it will convert a mechanical displacement into electrical output is called as secondary transducer. That is, the output of the primary transducer is converted into a useful signal by a secondary transducer. Okay, it is an electrical device. For example, LVDT, linear variable differential transformer. Okay, that is a secondary transducer. This both will be incorporated together in that primary transducer. In primary transducer, a physical quantity to be measured will be converted into a mechanical displacement, and in secondary transducer, this mechanical displacement output produced by the primary transducer, it will be fed as input into the secondary transducer, and it will be converting into a desired electrical form. Okay, now we will see. Here you can see this is the example for primary and secondary transducer. Here you can see a Borden tube, C-type Borden tube is there, and the input we will be applying here, it will be a pressure. Okay, pressure we will be applying as an input, and based on the pressure applied here, the pulley it will be changing, and the pulley it will be changing, and the output will be coming as displacement. As the pressure is applied, the pulley, the wire connected here na, so the wire connected here will be displacing with the help of this pulley. So output will be coming as displacement here, and this output is fed to a LVDT, and due to the change in this displacement, the core here will be excited. Here we will be having primary winding and secondary winding. Here we will be having ES1 voltage and ES2 voltage. So the based on the change in displacement, here the core will be excited. So due to this excitement of this core, the voltage here it will be changes. The differential output voltage here will be changing. So based on the pressure applied here, the voltage here will be changing. Okay, so this applied pressure will be same as the change in differential output voltage here. So here you can see this Borden tube is there. Borden tube will be the primary transducer. Here the pressure applied here, it is converting into the mechanical displacement. So that is primary transducer, and here you can see the LVDT secondary transducer. Here what will be happening? Here the displacement which is fed as output as primary transducer is coming as input to this LVDT. Okay, so the core will be excited based on the displacement changes here. So this displacement changes, it will be converting into a differential output voltage in this LVDT. So the mechanical displacement input fed here, it is converted into a desired electrical quantity. So that is what this secondary transducer LVDT is doing. Okay, this is the example for primary and secondary transducer. And also now we can see the various criteria of selection of transducer. Various criteria of selection of transducer will be like input characteristics will be there, output characteristics will be there, transfer characteristics will be there, then availability, cost, purpose, lifespan, etc. And in the input characteristics will be considering the input range, at what range it can operate, and loading effect. Loading effect means there should not be any change in input physical quantity due to the transducer used. So loading effect should be minimal in a transducer, because due to the transducer no change will be happening in the input. It should not, because of the transducer the input should not be affected. That is loading effect. So for a transducer the loading effect should be very minimal. Okay, so that is these are the input characteristics. And in coming to the transfer characteristics, the transfer function, that is the relationship between the input and output, should be linear, and also there should not be any error there, and the response of the transducer to the environmental condition also considered in the case of transfer characteristics. And in the output characteristics, the type of output, that is current or voltage. In case of electrical transducer, output impedance is considered, and the output range is also considered. Okay, and also some other factors for the selection of transducers are nature of measurement, depend on the nature of quantity to be measured, which for example, for a temperature measurement, temperature sensor should be used. So depending on the nature of quantity to be measured, which kind of transducer is used, we can decide. Okay, next one is loading effect, that I already told. Transducer should not affect the or it should not change the input quantity. That is transducer should not affect or changes the value of the parameter and the under measurement. That is, it should not affect the input. Transducer should not affect the input. So if it is affecting the input, it can cause error. So a transducer is selected to have a minimum loading effect to keep the errors to minimum. Next one is environmental conditions. Selection of transducers should be made under condition which transducer is expected to give a satisfactory output in severe environmental conditions also. Next one is measuring system compatibility. A transducer should be selected, and the electrical system used for measurement should be compatible. It should be compatible. The output impedance of the transducer and the impedance imposed by the measuring system must be in such that one does not adversely affect the other. That is, the input measurement quantity will be there, it will be having a impedance, and output also will be having an impedance. These both impedance should not adversely affect each other. Okay, that should be considered. And also next one is cost and availability of the transducer. That transducer should be easily available and cost should be minimum. Okay, and also transducer should be with minimal moving parts, so that the more moving parts means there is a chance of getting more error. So a transducer should be with a minimal number of moving parts. Okay, now we are coming to resistant transducer. We have seen here on the basis of method used for transduction. Transducers are classified into resistive transducer, capacitive transducer, and inductive transducer. Now coming to the resistant transducer. Here transducer based on the principle of variation in resistance are generally termed as resistance transducer. Here resistance will be varied, and the resistance variation in resistance will be converted into a suitable output form. Okay, variables like displacement, acceleration, vibration, force, pressure, temperature, etc. are transduced using a resistance transducers. Like displacement will be there, acceleration will be there, vibration will be there, force, force, pressure, temperature, etc. are transduced using this resistance transducer. For example, a change in temperature causes vibration of the resistance in a copper wire. Okay, that is, a change in temperature is happening. It will change the resistance of the copper wire, and this change in resistance will be converting into an electrical output. That is the how the resistance transducer is working. Okay, I told here so many physical quantities like displacement, acceleration, vibration, force, pressure, temperature, etc. Okay, based on the change in these quantities which is applied as input, the resistance of the wire will be changing, and this resistance of the wire, as the resistance of the wire changes, it is converted into the desired electrical output. Okay, that is how the resistance transducer will be working. And the basic principle of operation is based on the resistance of a length of a metallic wire is given by R is equal to rho L by A. This you have studied earlier in the various electronic subject, that is resistance will be equal to rho L by A, where rho means resistivity of the wire, L means length of the wire, A means area of the wire. Okay, R is in ohm, and rho will be in ohm meter, L will be in meter, and A will be in meter square. Okay, these are the various units of the measured quantity. R is equal to R, whereas R is equal to resistance, rho is the resistivity of the wire, L is the length of the wire, and A is the area of the wire. This is the basic principle of operation of a resistance transducer. Okay, here resistance is a function of rho L and A, and hence any change in rho L or A, the resistance of the wire gets changed. Okay, any change in these quantities, that is resistivity, length, and area, the resistance of the wire will get changed. Further change in resistance is converted to electrical voltage. I told in resistance transducer there will be change in resistance, and the change of resistance will be converted into a electrical output or electrical voltage. Okay, examples of resistance transducers are strain gauge, potentiometer, resistance temperature detector or RTD, thermistors, anemometer, etc. Okay, in that we are going to study about the strain gauge. So what is a strain gauge? A strain gauge is a resistance transducer whose electrical resistance varies in proportion to the amount of strain in the device. So in the input side, strain will be coming as input, and that strain will be converted into a desired electrical output. അതായത് ഇൻപുട്ടിൽ നമ്മൾ സ്ട്രെയിൻ അല്ലെങ്കിൽ സ്ട്രെസ് ഇൻപുട്ടായിട്ട് നമ്മൾ കൊടുക്കുന്നു, ആ കറസ്പോണ്ടിങ് സ്ട്രെയിൻ ഓർ സ്ട്രെസ്സിന് കണക്കായിട്ട് ഔട്ട്പുട്ടിൽ ഒരു ഇലക്ട്രിക്കൽ ക്വാണ്ടിറ്റി ആയിട്ട് അതിനെ മെഷർ ചെയ്തെടുക്കുന്നു. ഓക്കെ, സോ എന്താണ് സംഭവിക്കുന്നത് പറഞ്ഞാൽ ഇൻപുട്ടിൽ നമ്മളൊരു സ്ട്രെയിൻ അപ്ലൈ ചെയ്യുന്നു, ആ സ്ട്രെയിൻ കറസ്പോണ്ടിങ് ആയിട്ട് അതിൻ്റെ ഇൻപുട്ട് റെസിസ്റ്റൻസ് മാറുന്നു. ആ ബേസ്ഡ് ഓൺ ദ ചേഞ്ച് ഇൻ ഇൻപുട്ട് റെസിസ്റ്റൻസ് output is varied. Okay, output is varied means output voltage is varied. Okay, that is how the strain gauge works. So a strain gauge is a resistance transducer whose electrical resistance varies in proportion to the amount of strain in the device. Okay, strain means strain is the amount of deformation of a body due to an applied force. ഒരു ഫോഴ്സ് നമ്മൾ ഒരു ബോഡിയിൽ അപ്ലൈ ചെയ്യുമ്പോൾ ഉണ്ടാകുന്ന ഡിഫോർമേഷനെയാണ് നമ്മൾ സ്ട്രെയിൻ എന്ന് പറയുന്നത്. A strain is defined as fractional change in length. A fractional change in length നെയാണ് strain എന്ന് ഡിഫൈൻ ചെയ്യുന്നത്. Okay, it is the amount of deformation of a body due to an applied force. Here you can see in this figure, a material is having a length L and a diameter D. Here, when a force is applied here in this longitudinal direction, you can see a change in length, a delta L change in length is there. So that is called as strain. Okay, a body is there, a material is there with the length L and diameter D. When a force is applied here, you can see the body of the material is deformed, that is a length is increased. Okay, so delta L is the increase in length. So this is the strain here. Okay, from the figure we can define strain is defined as epsilon, which is equal to delta L by L, that is change in length divided by the original length. Okay, depending on the application of stress to any resistive wire, strain can be positive or negative. That is, force exerted here can be either in outward direction or in the inward direction. Based on that, strain can be classified as a positive strain or a negative strain. Okay, so strain can be based on the application, it can be positive or negative. And strain in the longitude direction or direction of length is called as longitudinal strain. So strain in the longitudinal direction or in the direction of length, it is called as a longitudinal strain epsilon 1. Okay, okay, strain in the longitudinal direction or direction of length as the force applied is called as a longitudinal strain. And the strain in the orthogonal direction or the direction of diameter is called as lateral strain or epsilon 2. Okay, strain in the orthogonal direction is called as lateral strain epsilon 2, and the ratio of the lateral strain to the longitudinal strain is called as Poisson's ratio, mu. Mu can be defined as the ratio of the lateral strain to the longitudinal strain, that is epsilon 2 divided by epsilon 1 is called as mu, which is called as Poisson's ratio. These all points you have to keep in remember. Okay, and the value of the nu or Poisson's ratio will be in between 0 and 0.5 for all metals. For all metals, the value of nu or Poisson's ratio will be in between 0 and 0.5. And the strain is dimensionless. Strain is dimensionless, na? It is delta L by L. It will be dimensionless, and sometimes it will be expressed as millimeter per millimeter or inch per inch. Okay, and also practically the magnitude of measured strain will be small, so it is sometimes expressed as micro strain or micro epsilon. Okay, generally the measured strain will be less, so sometimes it is expressed as a micro strain also. Okay, and also next one, when resistivity of a material changes with the applied physical quantity, it is called as a piezoelectric effect. If a resistivity of a metal changes when a changes with the applied physical quantity, or a force exert ചെയ്ത് ആ സമയത്ത് resistivity of a material change ചെയ്തു വിചാരിച്ചു, അതിനെ പറയുന്നതാണ് piezo resistive effect. And in a strain gauge, if a piezo-resistive effect is present, it is called as a piezo-resistive strain gauge. Okay. If a resistivity is changed due to an applied physical quantity, it is called as a piezo-resistive effect. And a piezo-resistive effect is present in a strain gauge, it is called as a piezo-resistive strain gauge. Okay. Now the working principle of strain gauge. We have seen previously that resistance of a conductor having a uniform cross-sectional area A and a length L and a specific resistivity rho is given as R is equal to rho L by A, which is equation number 1. Okay, If this conductor is subjected to a stress, there will be deformation, definitely. Okay, if this conductor is subject to a stress, there will be deformation in the body. Due to this dimensional change, the resistance of the wire will also change. Okay, if a force is exerted in that conductor or stress is subjected to that conductor, there will be a deformation in that body. Okay, and due to that deformation or dimensional change, there will be a resistance change for that the conductor. Okay, so let S be the stress or strain here. Okay, and also R is equal to rho L by A. So if this R is equal to rho L by A, if this quantity is differentiating with respect to S, where S is the stress or strain, you can see dou R by dou S, which is equal to, we will be differentiating L first, that is rho by A will be constant, dou L by dou S, plus now L by A we kept as constant and we will be differentiating rho. L by A into dou rho by dou S. Now rho and L we will be keeping as constant, and A will be 1 by A will be differentiating. 1 by A, if we are differentiating, we will be getting these are the constants, rho L divided by A square, minus when we are differentiating 1 by A, it will be minus 1 by A square into dou rho, dou A by dou S. So after differentiating R equal to rho L by A, we will be getting dou rho by dou S, which is equal to rho by A dou L by dou S, plus L by A dou rho by dou S, minus rho L by A square dou A by dou S. ഈ ഇവിടെ എങ്ങനെ മൈനസ് അല്ലെങ്കിൽ എ സ്ക്വയർ വന്നെന്ന് മനസ്സിലായോ? അതായത് 1/a നമ്മൾ എസ് വെച്ച് ഡിഫറൻഷിയേറ്റ് ചെയ്യുന്ന സമയത്ത് 1/a എങ്ങനെയാണ് ഡിഫറൻഷിയേറ്റ് ചെയ്യുക? a raised to -1 -1, that is minus of a raised to -1 -1, that will be minus of 1 by a square, normal differentiation. Okay, rho L by a square into dou A by dou S. Okay, and here dividing LHS and RHS by R, if you are dividing LHS and RHS by R, 1 by R into dou R by dou S, which is equal to rho by RA dou L by dou S, plus L by RA dou rho by dou S, minus rho L by RA square into dou A by dou S. Okay, we know R equal to rho L by A equal to rho L by R, L equal to RA by rho, rho equal to AR by L. We are changing here and there, so we will be getting this same equation. So here 1 by R into dou R by dou S, which is equal to RA by rho. RA by rho, we know RA by rho is equal to L. So 1 by L into dou L by dou S. Substituting will be getting like this only. 1 by R into dou R by dou S, which is equal to 1 by L into dou L by dou S, plus 1 by rho into dou rho by dou S, minus 1 by A into dou A by dou S, which is equal to equation number 2. Simple and derivation വളരെ simple ആണ്, just ഒന്ന് ശ്രദ്ധിച്ച് കേൾക്കുക. Okay, so 1 by R into dou rho by dou S, which is equal to 1 by L into dou L by dou S, plus 1 by rho into dou rho by dou S, minus 1 by A into dou rho by dou A by dou S, which is equation number 2. And also for a conductor, area is equal to pi R square. If R we are replacing with the diameter, pi d by 2, R is equal to d by 2. So pi into d by 2 whole square, which is equal to pi d square by 4. So A is equal to pi d square by 4. If you are differentiating this equation also with respect to S, we will be getting dou A by dou S, which is equal to d square is there. Pi and 4 are pi by 4 is constant. D square differentiating will be getting 2d into dou d by dou S. Okay, so pi by 4 into 2d into dou d by dou S. 2 and 4 will be cancelling here, 2 will be coming, so it will be getting as pi d by 2 into dou d by dou S. Okay, dou A by dou S equal to pi d by 2 into dou d by dou S. Okay, So here you can see 1 by a into dou a by dou s is there. So here we are getting dou a by dou s. So if you are making it as 1 by a into dou a by dou s, we can write it as pi d divided by 2a into dou d by dou s. Okay, 1 by a we are multiplying in both sides. So area we know that it is pi d square by 2. Substituting area here as pi d square by 2, we will be getting 1 by a into dou a by dou s is equal to, substituting here we will be getting like this, 1 by a into dou a by dou s, which is equal to 2 divided by d into dou d by dou s, which is equation number 3. So here equation number 2 is there, equation number is 3. Here you can see 1 by a into dou a by dou s. Here also 1 by a into dou a by dou s, we get it as 2 by d into dou d by dou s. So substituting this equation number 3 in equation number 2, here we will be getting 1 by r into dou r by dou s, which is equal to 1 by l into dou l by dou s, plus 1 by rho into dou rho by dou s, minus 2 by d into dou d by dou s, which is equation number 4. We are substituting what we got here into here, 1 by a into dou a by dou s ന് പകരമായിട്ട് ഇത് നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യും. അത്രയേ ഉള്ളൂ. That is equation number 4. Okay. And previously we have already told Poisson's ratio, it is defined. Poisson's ratio nu is defined as lateral strain by longitudinal strain. Okay, lateral strain by longitudinal strain. That is dou d by d divided by dou l by l minus dou d by d divided by dou l by l. That is Poisson's ratio. Lateral strain we have already told change in lateral direction, that is direction in the direction of diameter, that is minus dou d by d. And longitudinal strain we have already told the direction in change in strain in longitudinal direction, in the direction of length, so dou l by l. So Poisson's ratio is defined as minus dou d by d divided by dou l by l. Okay, so cross multiplying dou l by l, here we will be getting dou d by d, which is equal to rho into nu into dou l by l. So that is equation number 5, minus dou d by d, which is equal to nu into dou l by l, which is equation number 5. So substituting this 5 in 4. Okay, 5 in 4. Here we are getting dou l by dou s. Okay, instead of dou l by l is there. Instead of that dou l by l, we will be substituting this. Okay, sorry, instead of dou d by d, we will be substituting this. So minus dou d by d, which is we are getting as nu into dou l by l, which is equation number 5. So substituting that 5 in 4. 5 in 4 means here you can see dou d by d is there. Instead of dou d minus dou d by d, we will be putting it as nu into dou l by l. So 1 by r into dou r by dou s, which is equal to 1 by l into dou l by dou s plus 1 by rho into dou rho by dou s. Here you can see we are substituting here. Here minus is there, so here also previously minus was there, so it will become plus into nu into 2 nu divided by l into dou l by dou s. Okay, and also we can write dou rho by dou s, which is equal to delta r, dou l by dou s we can return as delta l, dou rho by dou s we can return as delta rho. Okay, substituting here we can write delta r by r, delta l by l, delta rho by rho, and delta l by l into 2 nu into delta l by l. Okay, so this is equation number 6. So where delta l by l is the per unit change in length, per unit change in area, dou rho by rho per unit change in resistivity, dou r by r per unit change in resistance. And also one important thing is the gauge factor of a strain gauge is defined as delta r by r divided by delta L by L, whereas gauge factor of a strain gauge is defined as rate of change in resistance divided by rate of change in length. This is very very important. Gauge factor of a strain gauge. Gauge factor of a strain gauge is defined as change in resistance, rate of change in resistance of a strain gauge to the rate of change in length of a strain gauge. That is delta R by R divided by delta L by L, which is defined as gauge factor. Okay. And also we know that strain epsilon, which is equal to delta L by L. Delta L by L is equal to epsilon. So delta R by R, which is equal to gauge factor into delta L by L. Delta L by L, we know that it is strain which is equal to epsilon. So delta R by R, which is equal to gauge factor into epsilon. That is equation number 7. Okay. So here we got the equation number 6. So dividing this equation number 6 with the delta L by L, we will be getting delta R by R divided by delta L by L, which is equal to delta L by L divided by delta L by L plus 2 nu into delta L by L divided by delta L by L plus delta rho by rho divided by delta L by L. So here we know that delta R by R divided by delta L by L will be gauge factor. Okay, gauge factor, which is equal to, here 1 we will be getting, here this will be cancelling, so we will be getting 2 nu plus delta rho by rho divided by delta L by L. Okay, delta L by L we can written as epsilon. So gauge factor, which will be equal to 1 plus 2 nu plus delta rho divided by rho epsilon. This is a very important equation for a strain gauge. Gauge factor of a strain gauge, which is equal to 1 plus 2 nu plus delta rho by rho epsilon. Where is nu is the Poisson's ratio, delta rho is the change in resistivity of that conductor, rho is the resistivity of that conductor, epsilon is the strain of that conductor, strain happened in that conductor, and GF is the gauge factor of the conductor. Okay. So expression for the gauge factor of a strain gauge is defined as GF, which is equal to 1 plus 2 nu plus delta rho divided by epsilon rho. Okay, and if there is no change in resistivity, means delta rho will be 0. So at that time gauge factor is defined as 1 plus 2 nu. Gauge factor is defined as 1 plus 2 nu, whereas GF is the gauge factor, nu is the Poisson's ratio, delta rho is, I told, change in resistivity, rho is the resistivity, and epsilon is the strain. And also strain gauge is of two types. One is bonded strain gauge, and then another one is unbonded strain gauge. In bonded strain gauge, the strain gauge will be attached to an elastic element surface. Here you can see, here strain gauge is there, it is attached to an elastic element, and force is exerted on that elastic element, and it is mainly used for this strain analysis. That is in Wheaton's bridge and all, we are measuring the unknown resistance now. So instead of unknown resistance, we will be putting this bonded strain gauges. Okay, and another one is unbonded strain gauge. Here it will be in this strain gauge, it will be having a moving part, moving element and a fixed element. Here you can see, here this is the fixed base, and here we are having that stretchable unbonded strain gauge wires are having, that is denoted here, and here one end it will be having a moving arm. So in an unbonded strain gauge, one end of the strain gauge will be fixed and the other end of the strain gauge will be having a moving arm, okay, or a moving element, okay. Based on that, the resistance is measured here. So that is unbounded strain gauge. So this is all about the resistance transducers. In the upcoming classes, we will be discussing about the other uh, transducers such as inductive and capacitive transducers. So that is all about today's class. If any doubt, please comment and let me know if you are having any doubt. Okay, so that is all about the resistance transducers. So with this, we will be winding up the today's class. Okay, thank you.